Now, this example, I guess it's just a little bit different. I've taken it from another textbook just to try to present to you a variety of style of questions that you could get. So it's saying, assume that the radius of the Earth is 6,400. Yes, nothing unusual there. Answer the following questions correct to the nearest kilometre. A, what is the circumference at the equator? Now, most of the questions are asking for distance, and this is asking for the circumference at. So circumference, we translate that just to mean the total distance, so we find the circumference. Even if you write these things down, maybe more thoughts will come to you as you're writing this. Find the circumference. That is the total distance around the Earth, but more than that, because it's at the equator on a great circle. Hopefully you've made the connection now between equator and great circle. So if I'm finding the circumference, I'm finding the total distance, I'm finding the distance on a great circle. I know that I use L is 2 pi r. We don't need the fraction. We don't want a fraction of this. We want the total distance. So 2 times pi times 6,400. And as you can see there, 2 times pi times 6,400 gives us this 40,212.3859. Correct to the nearest kilometre. So yes, we are going to be cutting off at the decimal point, cutting off at the 3, then won't impact on the 2. So it's 40,212 kilometres. B. What is the shortest distance? So we're back to distance. Shortest distance between 2 points on the equator, a great circle, radius 6,400. So on find distance on the equator, which is a great circle, which means r is equal to 6. Oh, they've told us 6,400. If they subtend an angle of 30 degrees, theta is 30 degrees. It's pretty straightforward. Use the formula. L is theta on 360. 2 pi r. Theta was 30 on 360. 2 pi 6,400, which you can see there gives 3351. So 3,351, and I'll be rounding it to the nearest kilometre. So the first digit I cut off as a 0. That's not going to have any impact. So it'll be this 3351. Now I know you can see me from what you can see, I'm not really writing the answer as has been instructed by the markers. But what you're including in there is a line I'm not showing with the full display from the calculator. So please make sure you're doing that, although I'm not doing it here. C, what is the distance? So again, find distance. So I'll probably be using my L equals theta on 360. 2 pi r. Between 2 points on the equator again, equator, great circle, what other things do we know? Great circle, r is the 6,400. If they are on opposite sides, so they're on the equator, And exactly opposite means we've gone around to here. If it's exactly opposite, it's gone half the way around. So we want half of this answer here. So we don't need our formula this time. The distance will be a half of 40,212, and that's 20106 kilometres. Should be right now to get started on exercise 902.